Hi students, I'm Abhishek from Vidyavaru, and in today's session I'm going to discuss some very interesting questions on HCF. I'm going to teach you the smartest, the shortest and the simplest methods for solving these HCF based questions. So if you like the video, please press the like button for sure. Share the video with your friends and don't forget to subscribe to our YouTube channel. While subscribing, press the bell icon also. That way you'll get the notifications of all our videos. As you can see, it's a complete English medium video, especially made for our students from South India, especially made for our students from Northeast India, like students from Telangana, Kerala, Karnataka, Tamil Nadu, all the students who have some difficulty understanding Hindi language. So what you need to do is be there till the end. You have to be there till the end because with each passing question, the difficulty level is going to increase. So do not forget to like the video. Let's move on to the first question. Let's see what is given on your screen. Find the highest number which on dividing 1656 and 2035 leaves remainders 5 and 3 respectively. That means this number does not divide 1656 completely. It leaves a remainder 5, and when it divides 2035, it leaves a remainder 3. That means it does not divide 2035 completely. So how do I proceed? I look at this 1656. I know that when 1656 is divided, the remainder left is 5. So if I subtract this 5, students, if I subtract this 5, then I'm left with 1651. And this 1651 will leave no remainder because the extra 5 has already been subtracted. What was extra has already been taken away. So 1651 will be completely divisible by this number. Similarly, if you look at 2035, so when 2035 is divided by this number, the remainder left is 3. Sure. So if I take away the extra 3, if I subtract this 3, I'm left with 2032. And now this 2032 will be completely divisible. Why will it be completely divisible? Because I have taken away the extra part which was 3. That means this number will completely divide 1651 and it will completely divide 2032. It is going to be a factor of both 1651 and 2032. We have to find out the highest such number. The highest such number which will divide both of them. That means highest common which is common for both of them. Highest such number which will divide both of them, which will be a factor of both of them. That means I have to find out the HCF, yes or no. The number itself, the HCF, the definition itself explains it. Highest common factor. So the highest factor which is common for both of them. So now let's find out the HCF. First up, I'm going to teach you the long division method. After that, I will teach you the factorization method from the next question. So now let's look at the long division method. Now let's find out the HCF. I've told you the long division method has to be understood. So now 1651 students is the divisor and 2032 is the dividend. Sure. So let's follow it. 1651 ones are 1651. So 2 minus 1, 1. 13 minus 5 is 8. 9 minus 6 is 3. 381. Now this 381 is the remainder. Students, this 381, the remainder, will become the divisor in the next step. So now 381 becomes the divisor and 1651, this particular divisor comes inside, becomes the dividend. Many of you already know how to solve it. I'm just going step by step to help you out. Sure. So 381 4s are 381 4s are 1 4s are 4, 8 4s are 32. So it becomes 1524. 11 minus 4 7. 11 minus 4 7. And what is that? Yes, I have 4 minus 2 2. So 127, 381. So 127 3s are 127 3s are. Yes, it is completely divisible by 127. So students, 127, which is the divisor in the last step, This particular 127, the divisor of the last step, will become the HCF, So what is the answer? The answer is option C, 127. It will completely divide 1651 and 2032. So if you like the smart approach of teaching, call upon the numbers which are given on your screen, speak with our representatives, and become a part of our live classes, become a part of our video courses which are available along with test series and study material. Next question is about something interesting. N is the greatest number that divides 676, 784 and 1024, leaving the same remainder. We are not aware what the remainder is. Now in this question, the remainder has not been given. A lot of students find this question difficult. Such a question has been there in the exams very often. Find the sum of digits of n. So we have to find out the sum of digits of this number n. So let's look at the three numbers which are given to us. 676, 784 and 1024. Sure? So how are we going to approach this question? What we have to do is look at the gap. We have to look at the gap in these numbers, the difference in these numbers. So what is the difference between 676 and 784? Very simply, I will subtract 676 from 784. Sure? So we will look at the difference that is there between these numbers. So 784 and 676 I'm subtracting. So 14 minus 6 is 8. So this is what? 0. This is 108. So this gap, this difference is 108. Sure. Now look at the next pair. What is the next pair? 1024 and 784. 1024 and 784. So let's look at the gap. Keep solving along with me. 784. So 4 minus 4 is 0. It becomes what? 12 minus 4. So it is 240. It is 240. Sure, we still have one more pair left. And what is that pair? Do not forget this pair. 676 and 1024. So let's find out the gap. 1024 and 676 will be subtracted. 14 minus 6 is 8. So it becomes what? 11 minus 7 is 4. So it becomes 348. So now look at these three numbers that we have. Students, we have found out the gaps between these numbers. These gaps are 108, 240 and 348. Sure? So to find this number n, which will leave the same remainder when it divides 676, 784 and 1024, how can we find this number? By getting the HCF, of the gaps. So let's find out the HCF of these numbers, the gaps which we have come up with. So 108, 240 and 348. Now I have to find out the HCF of these three numbers. Now I'm going to teach you the prime factorization method. I will write these numbers as a product, as a multiplication of prime numbers. Sure? So 108. What comes to your mind? What comes to my mind? 12 nines are 108. So 12 nines are 108, but I cannot write 12 and 9. I have to use prime numbers. So let me write 12 first. 2 square is 4. 4 threes are 12. And 12 nines are 108. So 9 can be written as 3 square. Yes or no? Look at it. I have written 12 nines are 108. So now let's aggregate the powers. So 2 square into 3 raised to power 3. Yes or no? Look at it. 12 nines are 108 has now been written in this form. 2 square into 3 cube. Sure? Now let's do the same thing for 240. Let's do the same thing for 240. 8 threes are 24. That is the first thing that comes to my mind when I look at 240. 8 threes are 24. So 2 cube is 8. 8 threes are 24. That's how I have written 24. 24 into 10 is 240. 10 can be written as 2 raised to power 1 into 5 raised to power 1, 2 5s are 10. That's how I've written it. Sure. Now let's aggregate the powers. How many 2's do we have? 2 raised to power 4. 2 raised to power 4 into 3 raised to power 1 into 5 raised to power 1. Yes or no? Look at it. So I have arrived at the prime factors. The same has to be done with 348 also. This looks to be a difficult number. Let's see. 48, the last two digits, students, the last two digits are divisible. The last two digits are divisible. 48 is divisible by 4, so the number is divisible by 4. So I will write 4 as this, 2 square. I know 4 is going to be a factor of this, 348. What am I left with? 348. If I divide 348 by 4, I am left with 87. Now 87 is interesting. 29 3s are 87. 3 raised to power 1 into 29 raised to power 1. Do not forget 29 is a prime number. 29 3s are 87. 87 4s are, you can check it. It will be 348. 7 4s are, yes, I was right. It is 348. Sure. Now we have arrived at, students, we have arrived at the prime factors. Prime factorization has been done. How to find out the HCF? Think only of the common factors. What are the common factors? 29 is there in 348, it is not there in others. So 29 is not a common factor. 5 is there in 240, but 5 is not there in 348. 5 is not there in 108. Sure, I have to think only of the common factors. So what are the common factors? The common factors are 2. Yes, 2 is present everywhere. 2 is there in each of them. 2 is there in each of them. So I have to choose the smallest power. of 2. So what is the smallest power of 2? Out here we have 2 raised to power 4, but the smallest power of 2 is 2 square. Sure. And now what is the other common factor? The other common factor is 3. Out here we have 3 cube, but in others we have only 1 power of 3. We have to choose the smallest power of 3. So it will be 3 raised to power 1. So finally this n, this number n has been arrived at. What is this number n? 2 square 4, 4 3s are 12. So n is basically 12. What is the value of n? N is 12. But the question was asking something else. Yes, this number n is 12, but let's find out the sum of digits. So what will be the sum of digits of n? 1 plus 2. It has only 2 digits. Very simple. It has only 2 digits, 1 and 2. So 1 plus 2, 3. Students, the answer is option A. The answer is 3. Let's look at the next question. Again, it is an interesting one. And now we have moved on to word problems. Do not forget, word problems are application of HCF. So this application cannot be missed. Even the next question is about the application. Let's crack it. 3 vessels containing 480 liters, 920 liters and 1400 liters of wine. We have 3 such vessels. The biggest measure that measures these capacities exactly. That means when we think of such a measure, it has to measure these volumes, 480, 920 and 1400. These volumes should be measured exactly. That means these volumes should be completely divisible by such measure. The measure that we are going to come up with has to completely divide these 3 volumes. So we have to think of the biggest, that means the highest. We have to think of the biggest such measure, the highest such measure which will divide these 3 numbers. That means it has to be a factor, it has to be a common factor of all these 3 volumes, of all these 3 numbers. We have to find out the HCF. Are you following it? Sure. Why are we supposed to find out the HCF? Because this particular measure, this particular volume has to be found out, which will completely divide these given capacities, these given volumes. Sure. So 480, 920 and 1400. We have to now find out the HCF of these numbers. So let's again do the same thing. Let's look at prime factorization now. Sure. What comes to my mind when I look at 48, 480? I think of 12 fours are 48. So 12, 2 square 4, 4 threes are 12. 12 fours are 48. So 4 is again written as 2 square. 12, 12 fours are 48. 48 into 10. 48 into 10. So 10 is now written as 2 raised to power 1 into 5 raised to power 1. I'm just telling you how to make it simple. Otherwise, you can keep dividing and things will remain complex. So now let's aggregate the powers. How many 2's do we have? 2, 2, 4, 4 and 1, 5. So 2 raised to power 5. Students, 2 raised to power 5 into 3 raised to power 1 into 5 raised to power 1. We have aggregated these powers. 12 fours are 48. Sure, you can do it yourself. It will be 480. Has to be expressed like this only. So now let's think of 920. So 920. So 920, when I look at 920, I know it is divisible by 10. Sure. So 10 can be written as 2 raised to power 1 into 5 raised to power 1. That is how I write 10. 92 into 10. 920 is 92 into 10. So 92. Students, 92 seems to be a dangerous number. 92 seems to be a dangerous number, but 46 into 2 is 92. Now 46 can be written as 2 into 23. It can be written as 2 into 23. 23 is a prime number. Look at it, students. 23 into 2, it is 46. 46 2s are 46 2s are 92, and 92 into this 10 becomes 920. Now let's aggregate the powers. How many 2's do we have? 1, 2 and 3. We have 2 cube. Sure. Then we have 5 raised to power 1 and we have 23 raised to power 1. Can you see that, students? Look at it. 2 raised to power 3 into 5 raised to power 1 into 23 raised to power 1. That is what it becomes. Sure. Now let's do the same thing for 1400. 2 sevens are 14. That is the first thing that comes to my mind. So 2 sevens are 14. 14 into 100. Now this time it is 14 into 100. 100 is what? 25 fours are. 25 fours are. So 25, that means 5 square. 25 fours are 100. Again, 4 is written as 2 square. Now let's aggregate the powers. 2 sevens are 14. 14 into 100. 100 has been written like this. 5 square into 2 square. So what does it become? 2 cube into 5 square into 7 raised to power 1. Now the prime factorization has been done, students. Prime factorization has been done. You have to choose the lowest power. You have to choose the lowest power of the common factors. What are the common factors? 23 is not a common factor. 7 is not a common factor. Even 5. Yes, 5 is a common factor. 3 is not a common factor. So 2 and 5, these are the common factors. What is the highest power of, what is the lowest power of 2 that we have? The lowest power of 2 we have is 2 cube. Think of the lowest power of 2. 2 cube. And what is the lowest power of 5? The lowest power of 5 is 1. So 8 fives are 40. Students, 2 cube is 8. 8 fives are 40. So the answer is 40. The biggest such measure is 40 liters. When you use a measurement of 40 liters, it will completely divide. It will completely divide all these values. It will completely divide 480. It will completely divide 920. It will not leave anything aside when you start measuring 1400 liters also. So with a measurement of 40 liters, you can measure them exactly. And now look at the last question for today's session. Again, an interesting question, a different type, very important from the exam perspective. Let's read the question together. A floor with dimensions 1.05 meter and 7.56 meter has to be paved exactly using square pieces of marble of similar size. Seems to be a very lengthy question. Let's make it simple. We have a rectangular floor. We have a rectangular floor which has these dimensions. It's a rectangular floor. Sure, the dimensions are 1.05 and 7.56 meters. Now, in this rectangular floor, what we are supposed to do? We have to cover this rectangular floor using marbles. But what is the shape of these marbles? The shape of these marbles is square. Sure? That means these square pieces have to be fitted exactly. That's the important part. These square pieces of similar size have to be fitted exactly so that we can cover this particular rectangle. Sure? Now the dimensions are given 7.56 and 1.05. Think of it like this. I must have square pieces. I must have such square pieces which the side of which will completely divide. Let's look at it diagrammatically. I have to think of such square pieces, a square piece which will completely, a square whose side, now listen to me very carefully, a square whose side should completely divide 1.05 meters, a square whose side should completely divide 1.05 meters, should not leave aside anything, yes or no, it should be completely divisible by 1.05. Again, 1.05 should be completely divisible by it. Even 7.56, the other dimension, even 7.56, the other dimension should be completely divisible by this length, by this side of square. That means you have to think of a number, the highest number, the biggest number, which is a common factor of 1.05 meters and 7.56 meters. Got the point? So let's make our lives easy. Let's convert these values into centimeters so that we don't have to worry about decimals. So 1.05 meter, what does it become? It becomes 105 centimeter. Very simple. I'm just converting it into centimeters. 7.56 meter will become what, students? It will become 756 centimeter. Now I have these two values. I have to find out the HCF. I will go with the long division method this time. You should know both of them. So 105 and 756. So 105 7 times. 7 times will be the best thing. So 5 7s are 35, 735. Now what is the remainder, students? 6 minus 5 is 1. The remainder is 21. Now this remainder 21 will become the divisor in the next step. It will become the divisor in the next step. And what will get divided? This 105, this 105, this divisor, this 105 will become the dividend now. So now it is very easy. 21 5s are 105. 21 5s are 105. It is completely divisible. So what is the HCF? Students, the HCF is the divisor of the last step. The HCF is 21. So the dimension is 21. The square piece which has a side 21 centimeter, it will completely pave this rectangular floor without leaving anything extra. So if you've liked my style of teaching, if you've liked our method of teaching, then call upon the numbers which are given on your screen. Become a part of our live courses, become a part of our video courses so that you can crack banking and SSC exams this time around. Thank you so much, guys. God bless you. Don't forget to like this video.